Hello viewers, welcome back to another section of our multivariable calculus tutorials. So we have a problem in triple integrals in spherical coordinate here. So in this tutorials we're going to solve this problem, which is triple integral of 3z dv, where e is the region inside both x squared plus y squared plus z squared equals 1 and z equals square root of x squared plus y squared. We've solved similar problems in our previous tutorials. So if this is your first time visiting this channel, kindly subscribe, and also you get access to our future and our previous videos as well. Now, how do we go about this problem? First of all, we have to express our limit points in the spherical coordinates. So, what are the parameters in the spherical coordinates which we are going to work for? We need our rho, which happens to be the radius of our sphere or radius in the 3D. We need our theta, then we need what? Our phi, right? So the next thing to do is to sketch what we have here. So we are going to sketch this. To sketch this, you realize that from the quadratic surfaces, x squared plus y squared plus z squared equals 1 is going to be an equation for a sphere, right? So x squared plus y squared plus z squared should give us rho squared. Then rho squared will be equal to what? 1. That is giving us the radius rho to be equal to what? 1, right? Yeah. Then since it's a radius, it's going to start from what? The origin, then it will skew around. So the limit for our rho is 0 less than or equal to rho less than or equal to what? 1. Then we are done for the rho. The next thing we are going to look at is our phi. Remember, we have this equation: z is equal to square root of x squared plus y squared, and this happens to be the equation of a cone from the quadratic surfaces, right? So we're going to base on this equation to find our phi, the angle phi. Z in the spherical coordinate is given by rho cos what? Phi, right? It's equal to the square root of what? R squared. Then we simplify this as rho cos of phi is equal to r. Then r in the spherical coordinate is also giving us what? R is equal to rho sine what? Phi, right? Then I'm going to get rho cos phi is equal to rho sine what? Phi. Then I can divide. So I'm going to get rho will cancel rho. Then I'm going to get tan phi is equal to 1. Therefore, our phi is simply equal to what? Pi on what? 4. Now the tan inverse of 1 is what? 45. So pi on 4. So let's draw what we have. Now, since we are having a cone, the cone is on the positive side, positive z-axis. So it's going to start from here and moves up. Then we have a spherical top like an ice cream. So we normally call this an ice cream solid figure in triple integrals, where we have a conical base and you have a small sphere up. So from here you realize that the radius of the sphere is 1. Falling on xy plane is going to be 1. When you collapse this on the xy plane, you're going to get a circle base here, where the circle will have a radius what? 1 to x and y side. So now we are done with our phi. Then what we are left with is, remember the phi is going to start from 0 towards pi on 4. The reason is it's on the positive z. In our previous tutorial we had a cone down. That is why we started from 5 pi on 6 towards pi. But in this case, we are on the positive side. We're going to start from what? 0 towards pi on 4 to get what you have here. So when you measure, you realize that it's 45, exactly half from the z plane. It's going to be what? Exactly half from the what? Z plane. So this is the interval for our rho. So for our phi, then we move to theta. We realize that there will be a projection of a fourth circle on our xy plane. Therefore, our theta is easily 0 towards 2 pi. Then I think we are done. We introduce our limits. Our phi is 0 to pi on 4, integral 0 to 2 pi, then finally 0 to 1 of 3z. You know that z is what? Phi cos what? Rho cos phi. Sorry, I interchanged the rho. Then dv, you multiply rho squared sine what? Phi, the rho, the theta, the phi. So at this point, what I'm going to do is to simplify. This is squared. I'm going to get 3 rho to the power 3 cos phi sine phi, the rho, the theta, theta d phi, then 0 to 1. Let me tackle the inner integral. So this is going to give me what? 3 over 4 rho to the power 4 cos phi sine what? Phi, right? And I bring my 0 to 1 here. So when I put 0, everything will be 0, but I'm interested in the 1. So I'll be left with 3 over 4 cos phi sine phi d theta d phi. Then I bring 0 to 2 pi. When I integrate this with respect to theta, I don't have any theta term, meaning I'm going to get just theta. So 3 over 4 theta cos phi sine phi. Then I bring my 0 to 2 pi here, then d phi here. So 0 here will be 0, 2 pi. So what I'm going to do is I'm going to put 2 pi here, and 2 pi is going to give us what? 3 on 2, right? When I put 2 pi here, I'm going to get 3 on 2 cos phi like this, sine phi d phi. So now this is what I'm getting here. Then the next thing I'm going to do is I'm going to integrate this with respect to what? Phi finally. Realize that if you have this 2 cos theta sine theta is always equal to what? Sine 2 theta. Therefore I can apply that here, so that I'll get 1 over 2 cos phi sine phi here. So these two cancel. Then I'll have my 3 on 2 here, integral 0 to pi on 4 here. So I'm finally going to get 3 on 4 sine 2 phi d phi, like that, 0 to pi on 4. Once I get this, I will integrate this with respect to phi, and I'll get 3 on 8, then that is negative cos of what? This, so sine to this, yes, so negative cos phi, 0 to pi on 4. What am I getting? Negative 3 on 8 out, so cos 2 open brackets pi on 4 minus cos what? 2 open brackets 0. Realize that this will give us what? 1 here, that is cos 0 is 1, then cos 180 is going to be cos 180 is negative 1. I'm going to have negative 1 minus what? 1, right? Then minus 3 on what? 8 here. So negative 1 then minus 1 here is giving me negative 2 multiplying. I'm going to get what? 3 over 4. Sorry, I omitted the pi. I have pi here because from here I was getting pi for my, so from the theta here I'm going to introduce a pi here, sorry, so I'll have another pi, so there will be pi part of my answer, and that pi is from the cos. When I integrated with respect to theta, I had theta there, so when I brought my 0 to 2 pi, I'm supposed to get 2 pi, but that 2 will cancel, so the 2 pi, when I come here, the 2 cancel 4, so I get 3 on 2 pi, so here will be 3 on 4 after I do. So here is 3 on 8 pi, so I'm getting 3 on 4 what? Pi finally. So this is the end of the video. Don't forget to subscribe and also what? Like, right?